So with that, I'd like to welcome Jennifer to the stage.
Can you guys hear that? There we go. So welcome. This is my first SPDK Summit. Anybody else first time? Oh, wow. That's incredible. Hooray. So here we are together. Thank you for joining us. I really think that today it's about how the hardware comes together with the software that all of you are building. Thank you for spending the time here with us today and tomorrow. I'm excited for the examples that some of you in the audience will be bringing up to share with one another about what you've learned in using SPDK, sharing those learnings with your peers here. So welcome to all of you, and let's get started with our first one together. A lot of keynotes will start with the data growth. But as I mentioned, it's really the combination of the hardware side as well as the software that brings about this new future. None of the future that you see on the screen would be possible without the combination of the application developers and the work that you do in conjunction with the hardware. Now, we all know that data is growing tremendously. It's being generated by the consumers, by machines, by automobiles, and the new experiences like VR that are being created by maybe some of you in this room. Together with sophisticated analytics, we're going to be able to unlock an even more exciting future, new revenue for businesses by really combining automated, computer-intensive artificial intelligence to unlock insights in that data. This is going to transform, and already is, manufacturing, online advertising, and many, many more domains. Business intelligence is expected to be the consumer of the majority of the compute, storage, and network resources in the very near future. In fact, IDC is reporting that just next year, $102 billion will be spent on business analytics. This is becoming a core capability of the data center, and everyone is looking for ways to get more out of the storage of all the data that they're collecting. The media prices have come down, and so the ability to collect more and more of that data is there, and it's making the need for pervasive analytics ever more real. Now, while everyone talks about the data growth, not many folks are talking about what does that place on the storage system requirements? And so what we see is that the storage systems are continuing to need more compute, faster network, faster media, as well as faster applications and software to keep up with the pace that the market's demanding for these analytics. So we'll spend the rest of our time really talking about software. This is our view of the storage solution, really. Software's at the top because it's really the hero. It's what's bringing together all the capabilities underlying that storage system. Off on, I guess it's my right, your right too, is the architecture. And this has been transforming over time, really bringing the data closer and closer to the compute node and to the processing power. The media has been accelerating and changing, and we'll talk about that in a moment. But with the advent of revolutionary technologies like the Optane SSDs, you're now seeing latencies reduced from milliseconds to microseconds. Networking is an often overlooked component in the storage system. And as we talk about more and more data being collected, it's being collected at the edge. It is being put into scale-out storage systems. The network becomes an ever more critical component of the storage solution. So we're going to talk about the networking solutions and software as well today. Memory has always been a critical part of a storage system. And with the advent of forthcoming persistent memory technologies, the latencies will be so low, the capacity so large, the need to ensure the software can take advantage of these new technologies is ever more present. As we've transitioned through different storage architectures, and there's more higher capacity, more drives being attached to each and every storage system. What we're seeing from our end at Intel is all of the storage system vendors, they're needing more and more compute power to drive all the technology, all the drives being connected to each and every node. So more processing power is needed. And then of course, accelerators are a critical component as well, where some very compute intensive algorithms, could be compression, could be encryption, are offloaded to FPGAs or to integrated accelerators like we have our Intel Quick Assist technology. So it's really all of these in conjunction with the software that we see is the complete storage solution. Now, the storage architecture has transitioned significantly over time. You can see in the upper left, the hard drives had tremendously slow latencies due to the mechanical nature of reading the sectors and finding the exact I/O. Transitioning over time to SSDs relatively recently. I mean, we've lived with hard drives for a very, very long time. And only recently are we really starting to see the pickup of the NAND SSD, which dramatically reduced the media latency and sort of starting to replace those high performance hard disk drives. The NVMe drives are providing even a greater transition. We're just starting to see more of an uptick today. And then the new media technologies we talked about, like Optane, really lowering that overall media latency. And then as I mentioned with that persistent memory, when we move to from I/O operations to memory operations, it transforms even more. So let's take a look at the latencies. So if you look at the storage architecture shift from a latency perspective, what you see on the left is the hard disk drive. Now to orient you to this graph, the blue is the media latency, the orange is the controller latency, and the green is the software latency. At the bottom, you'll see the contribution of software to the overall latency. So if you start at the left, I would have to increase the size of the slide by 100x to put it to scale to show the tremendous impact that the media latency of that mechanical hard drive has on the overall solution. It was so bad that the rest of the system was being optimized to hide that mechanical latency, media latency. Moving to SSDs, there was a dramatic improvement in the media latency, and it gave software a little bit more of an opportunity to have an impact on the overall solution. When they moved to NVMe drives, the controller latency and the code and the overhead that was associated with it was removed. And it's only when you start getting to these newer revolutionary media technologies that you really are changing the game even more. So it says 30%. It's a little hard for me to read, so why don't we blow that up? What you can see is that with new media solutions like Optane SSDs, the software solution now contributes 30%. Once it is that significant, that's actually a problem worth solving. So all the work that you're going to be talking about here over the next 2 days is really going to tremendously impact these newer technologies. And as I mentioned, the software becomes even more important when you move to the persistent memory domain. So Intel has been investing in storage software transformation for a very long time now. We've known that storage needed to move from that rigid silo to the scale-out software-defined world, and we've put many software libraries, you can see the 4 projects we'll talk about today, into open source, and we're even in fact the #1 contributor to open source. The 4 projects that you see here were put into open source because Intel's delivering hardware, and the software that we provide is system-level software. It's really the application that gets put on top of all that hardware that's making use of the underlying hardware and capabilities. So we want to help application developers like you accelerate your time to market and really focus on transforming your business if you're an enterprise developer by not having to worry about how to get the best out of the hardware. So these 4 projects are the ISA-L, the Intelligent Storage Acceleration Library, which is accelerating storage functions, the SPDK, which is accelerating the application performance. We have PMDK. This used to be known as NVML, if you were familiar with that over the last few years, now named the Persistent Memory Development Kit. And this provides an abstraction layer so that you are able to take advantage of the persistent memory underlying it. And the last piece is DPDK, the Data Plane Development Kit. We talked about how important network was to an overall storage solution, and this is our network-focused open source library to accelerate the network performance. So let's talk a little bit about each of these. The first and our leadership program for storage transformation is the Intelligent Storage Acceleration Library. And it's providing developers with an optimized implementation of the foundational algorithms that are really required to deliver modern data services, whether it's erasure coding, snapshots, deduplication. The open source library that Intel maintains and continues to contribute to is really there to help reduce your overall development lifecycle. So if you're starting your application development with ISA-L at the beginning, you can shorten the time to market and the ability to get the most out of your software when you're utilizing these libraries. Additionally, it allows you to spend your precious developer resources and time on value-add differentiated features. So a lot of benefits to you as a developer in utilizing these libraries. And even better, they were built with software-defined storage in mind. So whether it's in a native or in a virtualized system, the benefits are there it supports both environments. So Intel has licensed this library, which means that it will be compatible with both commercial as well as open source solutions. And many open source projects like Ceph and Swift are already utilizing ISA-L today. Because it's software acceleration, this can be deployed on existing heterogeneous environments. So the acceleration can be seen on existing as well as new deployments. One of our customers, Netflix, has published their results that they saw, and I'd encourage you to go look at that with ISA-L, where they're able to encrypt terabits of traffic, of their video traffic a day, every day. Utilizing ISA-L, they were able to accelerate their performance by up to 30%. So in summary, for every generation, every platform, ISA-L is going to ensure that you maximize the CPU performance, whether it's, again, from Atom to Xeon, and with the new processor capabilities, this is going to be your fastest way to utilize the tools and to get the best case performance out of the processor. Next is SPDK, and this is why you're all here today. So probably not a lot of introduction needed, and you'll be talking a lot about it with the SPDK team here on site. So again, while ISA-L is accelerating the storage functions, SPDK is accelerating the application performance. It's really comprised of these 4 main categories. The services, which include logical volumes, enabling a single SSD to appear as 20. We've put in a lightweight file system that uses a popular key value database, RocksDB. Additionally, block device abstraction is possible to allow the creation of composable virtual block devices. So you could have a compression engine encryption in those services. Protocols are enabled end-to-end. So whether it's NVMe over Fabric or iSCSI, both the initiator and the target are supported. And when we look at the drivers, we have driver support for NVMe drives as well as persistent memory and more. As far as virtualization goes, the implementation utilizes a virtual host, and this is enabling the performance and the efficiency to approach bare metal while still having all the benefits of virtualization. So really tremendous opportunity to speed up your application performance, and hopefully you'll learn from each other in the different talks today about the learnings for SPDK. Now, as a developer, technology is always changing, and it's probably very hard to know where to target your coding to. What we've done as we look forward to the future with persistent memory is we have created a way to future-proof, basically, the work that you're doing, so that you can write your code once and know that it'll work regardless of the device on the platform that's exposed. So whether it's persistent memory, hard drives, SSDs, or even a Ceph cluster. If you're utilizing this abstraction layer, which is really an extension of the software libraries for SPDK, you're going to be able to write your code once and see that benefit so that you have optimized performance in all of these platform configurations. So really a tremendous benefit for you, again, to go focus on the value add differentiating features of your application. The last piece is the data plane development kit. So this is an open source library, and it was really started with the focus of lowering the overhead for network packet processing. And it's really seen tremendous results. It's continuing to work on that network I/O performance, really accelerating the performance there. These libraries and drivers are targeted for native, virtualized, as well as container deployments. And it's been around for a long time. We have done optimizations across our different processor platforms as well as accelerators as well. So when you see the three main components, the drivers are helping to accelerate and increase the efficiency in moving data, both in hyperscale as well as in hyper-converged solutions. The abstraction framework is ensuring that whether an FPGA is present, quick assist technology, that it will be able to take advantage of those accelerators that are in the platform. So really enabling ease of use for you as a developer with those common APIs to be able to take advantage. And the core libraries that are offered with the development kits provide that foundational capability for memory management, PCI device management, and so forth. So if you haven't yet looked at DPDK, I'd also encourage you to, as we talked, the network performance is going to be critical for building this new future together. So just a couple more slides to intro you to your day, and as I told Nate, they didn't leave a break in your agenda, so I wanted to make sure that we went quickly and gave you a little time in the morning to have a break after Jim's session. Intel's put together programs. The Intel Data Center Builders was renamed recently. It's combining what was formerly our Cloud Builders program and our Storage Builders program into one. The benefits are still the same, and there is still a tremendous focus on the storage workloads and for storage builders. If you're not familiar with the Builders program today, some of the benefits include the Builders University. There's both online and offline courses available for new technologies. Additionally, there's something called the Builders Construction Zone. So as Intel is releasing new technologies, if you are looking to optimize your application performance on some of the yet-to-be-released technologies under a non-disclosure, you could gain access to that technology through the Builders Construction Zone. So I'd encourage everyone, if you're not familiar, to go visit Isella out at the table on one of your breaks and see what the Builders community could do for you. So Nate said this is our second SPDK Summit. The first one was last year, and it's been quite a year. Over 70 different companies participating. We're really excited to see that level of engagement as we've brought this to the open source community. And we have traditional storage vendors involved, tier 1, next wave cloud vendors, as well as application vendors, all participating. That's kind of the spirit of this community that we're excited to see here. There's also been 20 new features added in that time, including the vhost, the logical volumes, and more. Jim will talk about all the new features that have been added in his talk right after this. And lastly, we've seen a 100% increase in that visitor traffic. So really a big year. We're seeing a lot of momentum. And that brings me to my final slide, which is around a call to action for you. Over these next 2 days, please be engaged. And then when you leave here today, please be involved. Use SPDK. Please provide us feedback as well, so interact. It's really those real world applications and use cases. They're gonna help us uncover ways to improve the overall libraries and make them better for everyone. And then finally, contribute back to the community. It's your own way of becoming immortal by adding some of your own code back into this project. There's a lot of demos around SPDK. I'd encourage you to check those out as well. So that's all I had for this morning. I thank you again for coming. Like I said, it takes the software and the hardware together to really build this bright new future. So thank you.